evening everyone. So today we are going to discuss again current electricity. If you remember yesterday in previous class I have given you one question. I'm hoping that you all have tried, and if you see this question and if you have tried on Google also, you'll find that it is nowhere to be found because this question is exclusive and I personally created it. Although you can find another question which might resemble this, and you can solve this question by taking that topology, and it will be fairly good. Okay. So we will be discussing this question and few more questions, and I will be showing you how easy this question is if you just if you just pay a little bit of focus and think a little bit more, then this type of question you can do it fairly easy. Okay. So in this type of question, the only thing which can be bothering you is how to find, or if you remember a little bit of 11th, the only thing you might be find difficult is how to take elementary element. And why they are talking about elementary element also I will tell you for those who don't know. Okay, so we are discussing current electricity. I'll give you just a little bit of recap. We have discussed about the Ohm's law also, right? And we'll be thinking that it will be following the Ohm's law. And we have resistance also, that is rho L by A. And if you remember the formula of rho, what is the formula of rho? Is the formula of rho, right? And we can, if you remember the things, then I think we could have solved this question. Now mind, we'll try to solve this question, and how we'll be solving this question I will give first a rough idea, then I will let you try. You can pause the video and you can try itself. So the idea is, you can, this is what it is, like just like a solid hemisphere, but just the top is chopped off, and I guess I have given you the radius also. This was your r by 2 and this was your r. So this was the question, and the idea is, I'll give you the idea and then you can start again, that you can divide this hemisphere into very thin discs, right? And if you let's say this is the disc number n, and on the top of that you will have disc number n plus 1 and so on, right? And you can see as it will move, as you go from this point to this point, each disk will consume some of the potential. So the potential difference of each disk will be different. That means each disk will be your series. So you just need to find out the resistance of each disk and you just need to add them. I know we haven't discussed about the series and combination, but you have studied this in 9th, so I'm hoping that you can remember that. Let's say the resistance of each disk is R1, so R1 to R2 plus up to so on till Rn. So we can find the resistance of each disk and we can just simply add them, because if you see that all of them are just like on the top of each other, like there, and if you see the potential will gradually change. For example, this disk which will be here, let's say the bottom disk, and okay, battery is here. So let's say this potential will be V, and let's say this will consume, let's say V is for some, let's say the battery has 10 volt. Let's say the top one consumes 0.1 volt. So here you will have 9.9 volt, right? And up to so on, here you will get 0 volt. So this will also consume some potential. So the overall thing, what I'm trying to make another, again I'm expressing what, that all the disks will be in series. So we just need to calculate the resistance of each and every disk, and we can add them simply and we'll get our answer, right? But again, if you think, it is also complicated how we are going to find the disk. And what I'm saying, cut the disk into very thin slices, that means there will be n number of disks. How we are going to get the answer if there are n number of disks? So the idea is, find out the resistance of one disk and see on what variable it is depending, and find out that variable and see that the variable has linear relation or quadratic relation, whatever it is, and see how the algebra goes. Okay, so what we will do, we will take an elementary disk. Let's say this is the elementary disk. Okay, so this is the elementary disk, and this radius was r by 2. This radius was r. So we have this elementary disk, and we can say the radius here we will have r. And also, if you see, we can say that this disk is some theta degree above the horizontal axis. Here you can imagine your horizontal axis. So your disk is some theta degree above the horizontal. So if we go from 0 to up to this angle, we can completely cover all the disk. So the idea will be this. So we will take a disk here where it will make 0 degree, and from the top here then it will make some angle theta. And if you see, it is not complicated. If you just connect the line, you can guess the angle will be, because this is just r by 2 and this is going to be r. So you can guess this angle, and that means this angle is going to be 60. This basic trigonometry you can guess. So we'll go from 0 degree to 60 degree to completely take all the disk. Okay, and we can say this width is our dr. Okay, pay attention to this dr, and you can see this dr will also make some arc, and this theta is our d theta. This is very important point to be remembered. Okay, now if we draw the disk separately in different picture, okay, so this was the disk. If you see, this arc is dr, right? This arc is dr, and this is just our arc, right? We all know that any point from center to circumference, that will be a radius itself. So I can say, because it is also arc, I can say, we can say that d theta equals to what? Arc upon radius. So dr can be written as r d theta. Correct? And why we wrote r in theta terms, you will get to know in just a minute. Okay, this part is clear. Okay, so if you remember what is resistance, let's say the resistance of this disk is very small, because it is very elementary disk or very thin disk, so it is elementary disk. So let's say the resistance is dr. Okay, and if you remember, resistance of any material is what? Rho L by A. L will be the length where current is traveling. See, you can see like this, current will enter from this point and it will leave from this point. So total how much distance it will travel? This much distance it will travel, and we have to find what is that distance. Pay attention, this might be a little confusing if you get lost. If you take this section and if we zoom in, right, and if you remember from 11th, this d theta means very small angle. So if it is very small angle, that means this dr arc is also very small. If it is very small, we can treat them as tangent. We can treat them as tangent. And if we are treating them as tangent, that means this angle must be 90, because radius and tangent are always perpendicular. So by that logic, you can see we'll have this sort of triangle. So this length will be dr, this is our 90, and what we are interested to find, see current will enter from this point and it will leave from this point, so this much length only current is traveling, right? That means we are interested to find this value, right? Let's call it x, we are interested, or let's call it y, we are interested to find y. And if you see, if this angle is theta, that this angle must be theta, this will be your theta, so this will be 90 minus theta, so this will be theta itself. So if it is theta, you can now find what is your y. You can see, so y will be your dr cos theta. So our resistance is what, rho L by A. So L will be just like I explained here, y, A will be area of this disk, that is pi r square. Now if you substitute the values, you will find y is just what, dr cos theta. And now we need to care about r also. Why we need to care about r? Because you can see what was the first intention to find the resistance. We are going to go from 0 to 60 degree. In that case, the variable should be in terms of theta, but we can see variable is r also, because if you take this element, the radius is going to be r, and if you go on the top, the elementary radius is going to be r by 2. So radius is also changing. So we got two variables and we have to compress them in just one. So what we can write r as? So again I can show, explain by the picture. This was our radius and this is our r. So if you see, this angle is our theta, that means this will be just our r cos theta. So instead of capital R, sorry, instead of small r, we can see the variation of r is also in terms of trigonometric terms or theta. So I can write here r cos theta. Now you can see in complete equation, the variable is only theta. But another problem we have, that we are integrating in terms of dr. Why integrating? Again, integration is just what? Adding the things, very very small things. And why we are just simply adding? Because we can, I just told you that each resistance will be, each elemental disk will be just on top of each other. That means they are in series. So we have to just add them. So if you remember, we also defined dr in terms of theta. So we can just substitute that. Overall equation will come out to be dr equals to cos theta times, instead of dr we can write r d theta, and here we will have pi r square cos square theta. And now we can simply integrate 0 to r and 0 to 60. I am hoping that all of you know why we are integrating with this 0 to 60. You can see from the trigonometry also, this triangle, if you go from 0, this elemental disk to the top of the disk, what triangle you will get? You will get there r by 2, and this is your r, and this angle is theta. So this angle you can find, that is going to be 30. So we are going to get from this point to this point, then you will get 60 only. Okay. So now you just have to integrate this part. This part is only physics, up to which you are going to just do what? Integration. Nothing more physics is required now. You just have to do simple integration, and that you can do. Integration of dr will give you r. You can take out the constant. R will get cancelled out. You will have r and pi, and here you will get 1 by cos, that is just sec theta. Now you just have to integrate sec theta from 0 to pi by 3, and integration of sec theta, I guess, is ln sec theta plus tan theta, and you can put the limit 0 to pi by 3, and then you can put the limit and you will get the answer. So in this question or in that type of question, the only thing you have to worry about how you are going to take the elementary resistance. If you know how to take elementary resistance, then all the resistance either will be in series or parallel, that you have to find out. But the moment you will know whether it is in resistance, they are in parallel, then instead of dr you can write what, 1 by dr, right? And then you can do, and if they are in series, then it is simple, then also you can do. Just you have to come up with this expression, after which you can do it fairly easy. Now I don't think you want me to put the limit, or if you want, I can put the limit. Right, other thing is going to be 0, so I don't think I need to write, or right, so you can simplify that further, right? So understood all of you. So I'll give you one more question like this, so you can try on your base, so you can do your practice. This question will be common, you can find this question in many books, so this question is not something very new, but the previous question was something new, you cannot find anywhere, but this question is you can find in any good book. So I hope that you have seen this question. Now this question you can try, this question you can find in any books. You have a first term, current is entering from this point and leaving from this point, and this is your A, this is your B, and you have to assume that current is uniformly distributed throughout the cross section and the resistivity is rho. Okay, this length is also given, that is L. Because this question is common in many books, so I will not be doing it, but I will give you another question which might, or not might actually, which is quite like, which can be quite done by similar process of this. And that question is also something unique, you cannot find anywhere, so that question I will be giving you. That question is your homework, quite exclusive. But this question, that is influence. I was influenced by the previous one, so you can try this one. I'll give you time to try this one before I solve by myself. In that too, I'll be giving you just the limits and the last equation. Furthermore, I want you to do it, so I might not completely solve. I will give it to you. If this is your square, you have to think it as a square. It is taking time to draw. Okay, you have to think top and bottom as a square, and these 2 points are center of the points or center of the geometry. Okay, so my figure might not be that accurate, but what I'm trying, these 2 are center of the plane, and it might not look, but it is a square. Both of the faces are square, so top face is A, and bottom face is also square. That is also, it has a different dimension, but it also square. But it is solid. It is just like first term, but it has a square basis, or you can also think it like pyramid of square base, right? So this is the picture, and it is solid. Again, it is solid. You have to find the resistance. You can think that current is entering from this point and leaving from this point, and you can assume that current is uniformly distributed in cross section, and then you can find the value of current. That is your I'll give you one hint how to solve this question. See, if you see from side view, it will just look like this, right? Imagine that to be centered, right? It is just like this, right? So this will be our A by 2, and this will be our B by 2. If you see from the side, I think it is just going to look like this, and you have to find the resistance. And how we can find the resistance using this picture? I can take an elementary, this time not this but a sheet. I can take an elementary sheet of some width, right? Again, just like previous question, I can imagine that this first term can be chopped into many thin sheets, and if I stack each sheet on the top of each other, then each sheet is going to be in series with each other. Just I need to find the resistance of one sheet, and see, I just need to see how the resistance are varying from top sheet to bottom sheet, and that I have to summarize in one variable, and maybe then I can integrate to get the answer. So what I can do, I can say that from the top I have one y distance below, and then I have to do this and this distance I can take it as dy, right? So I can see, let's say the resistance of this disk is going to be very small, and you might ask why it is very small. Just like in this question it is small, you should ask why. So resistance is rho L by A, again by the fundamental of integral you should know this dy is very small. If it is very small, that means length is going to be very small, so resistance is also going to be very small. So dy is small, and I just need to see how it is changing. We can see from the top to bottom, area is going to change, and we will chop the disk of equal width. So the L is not going to vary, just the area is going to vary, right? That we need to calculate. I can again draw the picture here. Let's say this is the sheet, the width is dy, and if you see, I can draw this line also. This angle is going to be theta. That means anywhere if I chop the disk, this angle will remain same. It is quite obvious. And let's name this point A, B, C, D. It is going to be very thin. So whether I write DE here or DE here, it is going to be same. Nearly same, all should I say? Okay, because it is going to be very thin. So I can take and this anywhere this angle is going to be same. And that means I can use the similar properties of triangle formula, because if this is this angle is same, this angle is also going to be same, 90 minus theta, whether you take here, or this angle is always, another angle is always going to be 90. So, okay. Let's say this distance is x, right? So this distance is all again going to be a by 2. I think it is obvious to understand, right? If you want, you can switch the values. You can take this as x, and this as y, but no impact on that. And this distance is dy. Understood why I took why I said a by 2? Because this is just a parallel line, so this line must be same. So I can say the area of this is going to be very small, and area is just going to be what? Length into width. So I think because it is square, I think we should be able to get why I am going to write this. Understood? Because area of square, you know, this sheet is also going to be square. The area of square is just what? Side square, and side will be what? This distance is a by 2, this is also going to be a by 2, and because of symmetry, this is also going to be x. So total side will be what? A by 2 plus a by 2 plus x plus x, that means 2x plus a whole square. That is our area. And now I just need to find how I can see, because there are many variables, how far you are taking this, and what is the extra height from a by 2. So there are two variables, we have to compress these two variables into one. If you see the triangle, you can see triangle ADE is similar to triangle AB and I didn't write C, right? That means I can write the ratios are going to be same. That is, this distance was y, I didn't mention here, right? I can write, so this distance is also going to be y. So I can write DE over BC, D over BC equals to what? AE over BC. Sorry, AE over AC. Right? Similarity, the ratio of perpendicular or over the ratio of base, or if you want to take hypotenuse, will do the same, but hypotenuse is not going to be useful, so we didn't take. So if you see what is our D in the picture, it is just X. And if you see BC, it is what? This much extra length, right? If you see, pay really close, if you really pay attention, this length is, total length was what? B by 2, and this length is A by 2. So I can say this length is just what? B by 2 minus A by 2. So instead of BC, I can write what? B by 2 minus A by 2. And A, what is our A in the picture? It is just Y, and AC, it is just L. Now you can see there is somewhat relation between Y and X, and we will be using this relation and we will see which one we have to substitute. For now we are living in that form. maybe we'll use it later. Okay. So I said resistance is going to be what? Rho L by, so rho L is just what? Dy, because dy distance the current will travel. Okay. A is just going to be what? 2x plus a whole square. Now you can see from the integration, we are integrating with respect to y, but the variable is x, so we have to deal with it. And what is the integration of y means? Means the topmost disk will, sheet will be the top one, and the bottom one will be the bottom one, the last one will be the bottom one. So if we start from this point, the y will be 0, and if you reach to this point, the y will be the length of this. I didn't mention the length is L. So we'll be going from top to bottom, that will be just the length of system. So we can see we have to integrate in terms of y, right? So I need to convert x in terms of y, which I can write it like x will be your y by L times b by 2 minus a by 2. It doesn't look good. So, for simplicity of algebra, I'll write y times k. What is k? B by 2 minus a by 2 times 1 by L. Instead of all this, we'll write k. It will make our algebra a little bit more simpler to solve. And later on, we'll be putting the value of k that we can do. That means we just need to integrate. That will be 0 to r, and here we will go from 0 to L. Now it is just the integration we have to do. And substitute the values rho dy, and instead of 2x, instead of x we can write yk, so it is 2yk plus a whole square. You can integrate 0 to L. Now again there is a problem that how do we integrate this term? I think you might not know that much of integration, but we know only how to integrate like 1 by y square over dy, but it is y times some constant plus constant over whole square. How we are going to do it? So we will do substitution. We'll do integration by substitution. We'll let 2yk plus a as u. Don't worry about limits. The new limits we can write u1 and u2, and after that we'll substitute our y in terms of u in terms of y back, so there is no need to find it. So now because we are going to substitute y in terms of u, that means we are going to have new variable, and now we have to earlier we had to integrate in terms of y, but now we will integrate in terms of u. So we need to have relation between du and dy. You might think there is a lot of math, but it is true. There is no math, or there is no physics without math, so you have to do that much of math. So if we differentiate both sides with respect to y, we will get what? 2k plus 0 equals to du by dy, and there we will have the relation dy can be written as du by 2k. Got it? Now, instead of that, I can substitute, so that integration will give us r, that and here if we substitute, rho is already rho, and denominator to y k plus a we can simply write u, so it will be just u square, and dy can be written as du by 2k, 0 to, not to 0 to n, because there is new limit, you can write new limit as u1 to u2. Don't care about new limit because we will not need it. I will show you how. Take out all the constant, rho, 2k, all the constant, and 1 by u square we can write u raised to power minus 2 du, and now it is simple integration. I don't think you should be having any difficulties to integrate. That is just rho 2k. The integration of this is just going to be what? Minus 1 by u1 to u2. We got the integration, and now what we can do, we can just simply put our values back, right? What was our u? It was minus 2yk plus a u1 to and because the limit we are putting back in terms of u, you can put the initial limits, that was 0 to L. Now last step I will do, and you can do the further simplification. That is, what was your K? If you remember, it was just B minus 2 A by 2 minus A by 2 and 1 by L. You just put it back. That's it. And for the simplification, I hope you can do it. It is not difficult. You can do the LCM and all, and because of negative, you can change the limit. Lower will become upper, or upper will become lower, or you can do it by simple process, whatever you like, and you can simply get the answer. I'm leaving that point, and furthermore, you can do it. If you understand this question, I am hoping that you can do the previous one also, right? Same question, just same approach, just instead of sheet, you might have to take disk. I'm hoping that you will be able to do it. In next class, we'll discuss one or two more questions and we'll do one more experiment to show the proof of Ohm's law.